Okay, we're back finishing our notes off for day 3 of solving systems of equations. So again, we have two problems here that are the same. One we're going to solve by graphing, one we're going to solve by substitution. We should get the same answer on everything. We're starting to get into some problems that are a little bit more difficult, so I'm going to break this up into a couple videos. It might even be 3 videos that you got to watch on this one, but it's going to be a big help, I think. So here we go. So you'll notice that now y doesn't equal just a single number. In this one, y equals 2x. The one that we did before, it was like x equals -3. There was no y over here. And this one was said y equals 4. There was no x over there. Well, now we're dealing with both of our equations having both variables in them. So we've got to do that in a different way. You can't just say it's not giving us one of the answers to start with. So we have to substitute in a different way. So x plus 2, and we know we have y by itself up here, which means we can substitute y, that whole y out. The difference is I'm just going to make my area, I'm going to make my area a little bit larger, okay, to substitute my numbers in. So I've got 2x. So I'm taking my 2x and I'm substituting it for y. This 2 is this 2. This 2x is this 2x, okay? And I've got x plus 4x equals 10. And so I've got 5x equals 10, divide by 5, divide by 5, x equals 2, okay? So I know what x is. I know that x equals 2 now. That's a lot of 2's in there. That might be confusing. I know that x equals 2, but I got to find y now. And I can't just say y equals a certain number like I did in the last one, because it's not by itself. X on this one was by itself. Y on this one was, there was no other variable in that first one. So we need to actually substitute this guy back into our first equation. So it doesn't matter if it's the first one or second one. The first one in this case is a little easier. So I'm just going to take y equals 2. So I'm taking that whole equation. I'm going to make a spot for it. I'm going to take this x, what x equals, and I'm going to substitute it in there. And of course, 2 times 2 is 4, so y equals 4. So my solution to that one is 2, 4. We should get the same solution when we solve it over here. So our first one is already solved for y, so we can actually just graph that. My intercept is 0, okay? And my slope is 2, so I'm going to go up 2 over 1, up 2 over 1, and down 2 over 1. Okay. The second equation, though, it's not in the correct form, so you got to solve for y. You'll notice that there's a pattern here. The last two we had to solve for y. Everything we're having to solve for y here. So subtract x, subtract x. Okay. And I have 2y equals -x plus 10. So again, in keeping with like reminding you that the combining like terms thing here, these are not like terms. You're not going to write 9x, you're not going to write 11x. It is -x plus 10. You just write them right next to each other because they are not like terms. Okay, so 2, divide everything by 2, and we have y equals -1/2 x plus 5. So if you're somebody that's wondering, hey, where the heck did that -1 come from? It's sitting in front of the x. There's no 1 there. You just have to know that if it's a negative there or if it's just an x by itself, it's either -1 or there's a 1 there. There is a number there. And then we're going to start off at 5. So 1, 2, 3, 4, 5. And now we're going to go down 1 and over 2. And look at that. Our first down 1 and over 2 got to our point where we were crossing. So we're going to draw our line. Okay, we're going to draw our line. And we have our solution as 2, and then 1, 2, 3, 4. Okay. All right, so now probably the most difficult problem that you're going to have to work with in your homework tonight. You have an equation where you have to solve for, you have it solved for y, but the numbers aren't right next to each other. It's not like 2x, right? Well, it's still y equals something. And so you're going to take this whole thing and you're going to substitute it in for that y. So we're now substituting kind of more here. And we've got to have a whole big parenthesis in there. You notice as we're going through, our parentheses are getting larger to fit more stuff in them. So we have negative x minus 1, okay? So I've taken this y and I've replaced it with those parentheses that we've been using, okay? And now we have negative x minus 1 in there. So if there was like a 2 out here, or if there was another number in front of the y, we'd have to distribute that in, and I'll show you what that looks like. Hopefully on the back, I think I've got some of those problems on there. And in this case, we don't have to. We can just go straight to negative 3x minus 1 equals negative 5. And negative 4x minus 1 equals negative 5. Add 1, negative 4x equals negative 4. And look at that, this problem just by chance worked out perfectly. X equals 1. Okay, so if x equals 1, we're going to take that and we're going to substitute it back. I'm going to just use the first equation because that's a little bit easier. And I'm making a template for the x. So you see how I left that negative out there? That negative's got to stay out there. And so you put your 1 in there. And now you have negative 1 minus 1, y equals negative 2. So write it as an ordered pair, 1, negative 2. Okay, so this is 1, this negative 2. Okay, so really, like, the name of the game on substitution is you substitute in once, you find one of them, you substitute that number that you found again, and then you find the second one. And so sometimes you'll be finding the x first, and sometimes you'll be finding the y first. We are now going to graph this one. I'm just going to solve for y. I'm not going to graph this one in the interest of time. I don't want to waste your time on it too much. But I will say that you're probably going to have to solve it for y, and this will be y equals 3x minus 5. Okay? And then you would have to graph those just like we did the last 3. I don't want to do that part because you guys have graphed a ton in the class, so I don't want to do that. I want to focus on the new thing. So let's focus on that new stuff again. All right, so you can see the problems are starting to get a little bit more difficult. Okay, so we have 2x plus 6 equals y, and then negative x plus y equals 3. So you really got a choice of one of two ways here. You can solve for y on both of them and set the equations equal to each other, or you can substitute in. I'm gonna do this problem one way and this one, the second one, a different way, just to give you guys a little bit more practice and show you that there's more than one way of doing this. And on the test and in your homework, I really don't care which way you're doing it, as long as you're using some form of substitution. If I ask for substitution, you need to substitute. Okay, so this guy right here, let's solve for y. So let's add x to both sides. And we have y equals x plus 3. Okay. Well, we have a y by itself here and we have a y by itself here, right? Well, that means that if y equals y, then whatever this is must equal whatever this is. So this is 2x plus 6, and it must equal x plus 3, because 2x plus 6 equals y, and x plus 3 also equals y. So you can rewrite the whole equation again, and we kind of introduced this in class in the second lesson as 2x plus 6 equals x plus 3. Okay, so subtract x from both sides. And we got x plus 6 equals 3. Subtract 6 from both sides. We've got x equals negative 3. Okay? And so that's our x equals negative 3. Now we need to substitute back in to find y. Well, I'm going to take that first problem, and I'm going to open up x now. Okay, so 2 times x, well, we're going to replace with x here. Negative 3 plus 6 equals y. So everything else is the same, right? Y is y, 6 is 6. X is now negative 3, and 2 is 2. Okay, so this is negative 6 plus 6 equals y. If you're wondering why this is negative 6, a negative times a positive is a negative. 2 times negative 3 is negative 6. Negative 6 plus 6 is 0. So negative 3, 0 is your solution. Okay, so that's one way of doing it. If you solve them both for y, you can write them equal to each other. The other way of doing it is taking y or taking this part of the equation and substituting it in for y. So both work. They're both going to get the same. They're both going to get the right answer. It's just some people see it one way and it's easier for them. So I see it this way. So I'm gonna do this problem one last time. So 2x minus 2. We're going to substitute that whole thing in for y. Okay, and we have 2x equals 2x minus 2 minus 4, and we're going to subtract 2x, and we get 0, and we get a 0, and we get negative 6. Whoa, what the? Okay, what does that mean? 0 equals negative 6? Is that true? That's false. Okay, so this one we might actually want to graph and see what's kind of happening in the graph. So far we got a really weird answer. 0 is negative 6. So we're going to try to figure out why. All right. So let's come and graph, and we're going to graph our first one. We got negative 2. We're going to go up 2 over 1. Up 2 over 1. Up 2 over 1. And we can graph that. Okay. All right, our second problem, though, we need to solve for y first. So subtract 2x from both sides. Actually, no, we're going to do that a different way. We're going to add 4 to both sides. Because if we move 4 over here, y is by itself. And we have y equals 2x plus 4. Okay, so we're going to go up 4 spaces. And we're going to go up 2 over 1. Okay. So, they're not crossing. So there is no solution. So remember when we did our first day in this series of lessons, it was no solution if they're not crossing. Well, there's no solution. After we graph it, we see that there's no solution. So when we get something weird like this, right, where we get 0 equals negative 6, or we get 1 equals 5, and we get something that's false, that means there's no solution. The lines never touch. So we're going to do one last one. I think this is another important one. It's one of those little tricky ones. So we're going to take y and we're going to substitute it again. So 3x plus, and we got a bigger area to substitute in. So this negative 3x is this negative 3x. This space right here is y. This equal sign is this guy. Negative 3 is negative 3. We're going to take this whole thing and substitute it in. So 3x minus 3. And we're going to distribute the positive 1 that's there, but anything times 1 is itself, so everything stays the same. And look at that. We get 0 when we combine like terms. So we have negative 3 equals negative 3. Well, this is true. So if a false answer is no solution, what do you guys think a true answer is going to be? Well, before I give you the answer, let's look at what our graph says. So we have everything is solved for y here. So we start off at negative 3, and we go up 3 over 1. Up 3 over 1. Remember, if there's no 1 under it, it's over 1. So up 3 over 1. We're going to... Okay. So that was our first one. The second one, let's solve for y. We're going to add 3x to both sides. And that's y equals 3x minus 3. Oh, wait a minute. Isn't that the same thing that we just graphed right here? They're the same lines. So that means there's an infinite number of solutions. Infinite solutions. They're the same line, so if the two equations equal each other, they're right on top of each other. They're infinite solutions, okay? All right. So that's it for today's lesson. I know this was kind of a longer one, but the more examples I do of this one, I find that people get a little bit better at it. So I'm going to save this last one for class. So good luck to you.